Do you know why our species like mysteries? Perhaps because our existence is dwelling in mystery. Since the beginning of time, it has been questioned and argued that where do we come from? Is it out of nothing? Or is there a method to this madness of the world? Can we take refuge in the stories of God? Or is there any logical explanation? Is there any meaning mounted above in the skies or deep beneath the earth? We need to understand the ground where we live and occupy, known as Earth. Our planet was born roughly around 4.5 billion years ago. At first, there was only cosmic dust containing matter and energy, which due to gravitational pull collapsed with each other and formed a small football, which over time grew larger by repeated collisions of these dust. Earlier, there are two widely acceptable theories that explain the creation of Earth. First one is the core accretion model, which suggests that the solar system was a giant cloud of dust and gas known as solar nebula before the formation of Earth, and due to gravity, matter and energy collapsed in on themselves as it began to spin, which created the sun in the center of nebula. Smaller particles bound into large particles with gravity, while the solar wind swept away lighter elements, leaving the heavy rocky materials to create a terrestrial world. That's when Earth's rocky core formed, as the heavy elements starts colluding and binding together. Highly denser material sank to the center, whereas the lighter pieces created the crust. And gravity absorbs some of the lighter elements that create the makeup of the planet's early atmosphere. Let's dive into the second model, the Discinstability model. It suggests that the giant gases need to evolve rapidly to grab hold of the significant mass of lighter gases they contain. So, this process spans over millions of years, which was longer than the light gases available in the early solar system. That's why a smaller cluster of dust and gas bound together in the life of early solar system. Then these little clusters compact into a giant planet. This model differs from the core accretion model as it defines the birth of a planet much faster by allowing them to trap rapidly vanishing lighter gases. But this theory was debunked in the 1960s with the Apollo space program, which changed the view and scope of the creation model because studies of moon craters reveal that the gouges in the surface were caused by the impact of objects that were in great abundance about 4.5 billion years ago. Thereafter, the number of impacts appears to have quickly decreased. This observation reignited and confirmed the theory of accretion, and since then, the scientific community came to an understanding that the planet's size grew gradually, step by step over thousands of years. A calculation made by George W. Wetherill of the Carnegie Institution of Washington, who concluded that about 100 million years could pass between the formation of an object measuring 10 kilometers in diameter and an object the size of the Earth. Scientists also believe that the next stage involves the collision of a protoplanet with a very young planet Earth. This is thought to have occurred more than 4.5 billion years ago and may have resulted in the formation of the Earth's moon. Final stage of development saw the bombardment of the planet with asteroids. That's why the Earth's early atmosphere was most likely composed of hydrogen and helium, although there are many theories that arrive from the scientific community time to time, but accretion model seems to be the most plausible one as it further paved the understanding of Earth because it laid the foundation of thermal consequences for Earth that forcefully directed its evolution. Large bodies ripping into the planet produced immense heat in its interior, melting the cosmic dust discovered there. The resulting furnace, situated some 200 to 400 kilometers underground, is known as magma ocean, which was heavily active for millions of years, giving rise to repeated volcanic eruptions. This is why the younger Earth was not inhabitable, as it was constantly being bombarded with huge objects, in which some of them perhaps the size of the moon or even Mars, along with the heat as its surface by volcanism and lava made the life impossible to exist. And gradually it went into a cooling period over millions of years, which made the evolution of our species possible. But how it became habitable? The answer lies in the composition of Earth, or like the old proverb goes, the devil is in the detail. The heart of our planet lies in the inner core, a solid sphere of iron and nickel that's 759 miles wide and as hot as 9,800 degrees Fahrenheit. The inner core is surrounded by the outer core, a 1,400 miles thick band of iron and nickel fluids. Beyond the outer core lies the mantle, an 1,800-mile thick layer of treacherous molten rock, on which Earth's outermost layer and its crusts rest. On the surface, the continental crust is an average of 19 miles thick, but the oceanic crust that forms the seafloor is thinner, with about 3 miles thick and denser. The atmosphere of Earth is 78% nitrogen, 21% oxygen, and 1% other gases such as carbon dioxide, water vapor, and argon. Similarly, like a greenhouse gas, this blanket of gases absorbs and retains heat. On average, the surface temperature of Earth is about 57 degrees Fahrenheit, but without our atmosphere, it would be 0 degrees. That's why, over the last 2 centuries, human activities has caused a rise in average temperature by 1.8 degrees Fahrenheit. This extra heat has altered Earth's weather patterns in several ways. That's why the search to find Earth-like planets have been speeded up, and which did not happen as a consequence. But back in 1925, an American astronomer, Edwin Hubble, made this discovery that our universe is expanding, which laid the foundation of Hubble's law, revolutionizing the scope of our understanding about the galaxies. Since then, many planets and stars whose atmosphere is Earth-like are discovered throughout the years. Perhaps the father of geology rightly concluded the theory of Earth with this phrase: no vestige of a beginning, no prospect for an end. That is why, when there is no beginning and no end, then why we contemplate on reaching either way? Maybe we can find ourselves stuck in the mystery that is full of life and love, and if we only can cherish the little moments that we occupy in an ever-expanding space.